Hello, and welcome to Algebra Unit 3, Concept 2, Lesson 4. Today, you are going to factor polynomials using the greatest common factor, otherwise known as the GCF. Make sure that you're completing your notes as we go. So, factoring is just another use of the distributive property. So we know that when we distribute it, if we distribute 5x to 2x squared minus 3x plus 4, we get 10x cubed minus 15x squared plus 20x. So in factoring, we're just going to go the other direction. We're going to pull that greatest common factor out of the numbers. So how can we find the greatest common factor? Well, that's real easy. All we can do is just go ahead and separate these numbers down into their prime factors. So for negative 18 y to the fourth, I know it has 4 y's. So that's 1, 2, 3, 4 y's. And then it also has a negative 1 because it's negative. And then it's 3 times 6, which is 3 times 3 times 2. Times 3 times 3 times 2. And if you don't know what these are off the top of your head, you can do prime factorization on the actual number. But of course, the y's, you're going to use the exponent to give you the number of y's. So then I have 6y cubed, and that is simply y times y times y. I've got 3 y's. Times 6 is just 3 times 2. And then 24 y squared is 2 y's, and then 24 is 2 times 2 times 2 times 3. Again, if you don't know the prime factorization, then you can go ahead and do your prime factor tree like we did in Concept 1. Now all I'm doing, now all I'm going to do is I'm going to figure out what these have in common. Well, they all have 2 y's, right? So they all have 2 y's. So they have that in common. They all have at least 1 3. And they all have at least 1 2. So the greatest common factor is going to be a combination of that. It's going to be 3 times 2 times y, which is the same thing as 6y squared. So, in this case, my greatest common factor is 6y squared. Now, in order to actually finish factoring this, then what I would do is take what's left. So for negative 18 y to the fourth, I still have 2 y's, a negative 1, and a negative 3. Negative 1 times negative 3 is negative 3. And then I have 2 y's, so I have y squared left. For plus 6y to the third, I have left just a y. So that's just going to be plus y. And then on the 24y squared, I have just 2 2's, and 2 times 2 is 4. So that just becomes a plus 4. You can double check these by simply multiplying it back out. Yeah, different problem. Okay, so this next problem, again, we have the option of going through each of these numbers to figure out what the greatest common factor is. We do this because we don't just want any common factor. We want the greatest common factor. This time, though, I'm going to skip going through the y's. I can tell, looking at these, I've got a y to the sixth, a y to the fourth, and a y to the third. So I know that my greatest common factor is going to be a y to the third power, because they all have at least 3 y's. So I'm just going to look at the numbers. So negative 16 is negative 1 times 2 times 2 times 2 times 2. 28 is 2, which would be 14 times 2 times 7. And negative 20 gives me negative 1 times 2 times 2 times 5. So again, I'm looking for what they have in common. But this case, I'm going to do something a little bit different. So you'll notice I have a -1 in my leading one. So we're going to pull out the -1. I'll show you how that works. The other thing so that gives us a -1 for each of those. And then there's 2 2s, 2 2s, 2 2s. Well, -1 times 2 times 2 simply gives me -4. So I have -4y. However, notice I couldn't pull out a -1 out of this one. That means this one is going to become negative. It was not before, so we're going to change the signs and everything. So in this case, when I look at what's left here, I have 2 2s. So that becomes 4, and then I had 3 y's left. 4y to the third. The 28 becomes negative, and all I have left here is a 7 and then a y. And then for -20y to the third, all that's left is a 5. So my final answer for this one would be -4y to the third times 4y to the third minus 7y plus 5. An important thing to remember is that they like you to make sure that this first leading coefficient is positive when you're factoring. So if you ever do one and it comes back and tells you it's wrong and you have left that negative, sometimes they will mark that incorrect if you don't pull out the negative. Okay, so now let's talk about how we can use this. So Alani is in charge of marketing for a travel company. She's designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. What is the total area of the photo? So we need to look down here. So there are 2 main square photos that have a length of x inches on each side. So the squares are all x by x. And there are 4 narrower pictures that are 1 by x. So these would be 1, 1, x. So we have 2x squareds. And then we have 4 that are 1 by x, so they're x is their area. So that is the area, the total area of the photos. 2x squared plus 4x. Because each of the narrower photos are 1 by x. Okay, not too bad. 2x squared plus 4x. So now they're asking us to find a rectangular arrangement for the photos. And then describing what factoring represents in this arrangement. So remember that we had said that this was 2x squared plus 4x. What factor could we pull out? What is the greatest common factor? Take a minute, pause, and see if you can factor this. Okay, hopefully you paused. So you should be able to pull out a factor of 2x. So if I pull out the factor of 2x, what's left inside? I have x plus 2 left inside. Now, what does that factoring represent about the arrangement? So remember, when we're talking about arrangements, we're talking about something about length times width, right? Length times width. So one of these would be the length, one of these would be the width. Each factor, the 2x is one factor, the x plus 2 is the other factor, would be one or the other. So they asked you to factor out the GCF for the polynomial. What does the GCF represent in this situation? Remember we said it was 2x times x plus 2. What does the greatest common factor represent? It would represent the tallest or widest we could make it, depending on which direction you said that was. Finally, let's look at this. Which of these 2 arrangements is a more practical use of space? So here we have an arrangement on the left that is x by 2x plus 4. And over here on the right, we have an arrangement that is 2x by x plus 2. So which of these is a more practical use of space? Well, it would depend, right? It would depend how we want to arrange things. I think, though, typically the one that is closer to being a square is usually our more practical use of space because it can go in more spaces. However, you might want to use this one that's more vertical if you want to just have it all at the top or bottom. Just different ways to think about it and different ways to have factored it. Okay, so go on to your work in Savas and then your mastery check, and I will see you all in class.